Good morning, everyone, and thank you for joining us for today's webinar, Manure Nutrient Management Research and Best Practices to Preserve Water Quality. My name is Julia Freuk, and I'm the project coordinator here at the Partnership for Ag Resource Management, and will be hosting the webinar this morning. We are joined today by my colleague, Mark Adeslperger, Resource Management Specialist for the Partnership for Ag Resource Management, who will provide a brief introduction. I am also pleased to welcome our guest speakers, Dr. Melissa Wilson, Assistant Professor and Extension Specialist in Manure Management and Water Quality at the University of Minnesota, and Chryseis Modderman, Extension Educator of Crops and Manure Management at the University of Minnesota Extension. Before we begin, I will go over some brief logistics. Please make use of the question box on your screen to type questions for Dr. Wilson and Chryseis during their presentations. I will moderate the questions during the last 10 minutes of the webinar after the presentations. This webinar is being recorded and will be available later on partnershipfarm.org. By attending today's webinar, you are eligible for 1.5 CCA continuing education units, 1 for nutrient management and 0.5 for soil and water management. You must be present for the entire webinar to receive those points. You will receive an email in the next few days with the webinar recording and a webinar evaluation. Please make a big note that credits often take a few weeks to appear in your account. If it has been more than 3 weeks, please contact my email at julia@partnershipfarm.org. If you are watching this on demand at a later date, please be sure to watch the entire presentation through the GoToWebinar platform and not YouTube to receive credit. A link to register will be provided in the text below the YouTube video recording and on our website, or it will be emailed to you if you have already registered for this webinar. If you watch the webinar recording more than 2 weeks after the original broadcast, please email julia@partnershipfarm.org your CCA number to ensure your CEU credits are submitted. And now, with the logistics taken care of, I will turn it over to Mark.
Well, thank you, Julia, and thanks everyone for joining us today. It's kind of a cold, dreary day where I'm at here in Ohio, but thanks for joining us. The Partnership for Ag Resource Management it's an effort of our nonprofit IPM Institute, along with many other projects in agriculture and communities, each focused on using the power of the marketplace to improve sustainability. Our team of 23 is currently working to increase adoption of best management practices and improve outcomes in health, environment, and economics, all key elements of sustainability. We write regularly on IPM and other topics for Crops and Soils magazine. Our article on corn disease is one of the most recent issues. We also work with pest control companies, hospitals, schools, and other facilities and communities, and with food companies and farmers around the world to improve practices and performance, and to communicate those benefits to buyers and the public. Next slide, please. Our goal with Partnership for Ag Resource Management is to identify revenue opportunities for ag retailers to keep our valuable ag resources on cropland, help promote those products and services, and track sales through annual surveys and estimate reductions in losses of nutrients and other inputs that result from these sales, and report sales back to participating ag retailers for their location and state and regional averages. We work with ag retailers and industry associations to publicize these great contributions through press releases and articles. It's very important to get this positive news out to address misperceptions the public has about agriculture. We're all aware of the water quality challenges we face, from the record-breaking algal blooms in western Lake Erie Basin to the larger-than-ever hypoxic zones in the Gulf of Mexico. And we also know that agriculture can make a difference. There are many signs of improvement in the Chesapeake Bay, for example, after a couple of decades of focused efforts to identify and implement solutions, including cover crops. Next slide, please. These two photos show what happens when too much phosphorus gets into the water, feeding blooms of algae, which close beaches to swimming, making fishing a challenge, and having to also shut down public water supplies. The graph at the top shows NOAA's annual data on algal bloom severity since 2002. After phosphorus loadings declined sharply in the mid-'80s, with the advent of reduced tillage, they have increased, and as a result, we've experienced more frequent and severe algal blooms. We know the phosphorus is coming primarily from cropland because of the timing of the loads, the spike during snowmelt and rain events in winter and early spring following fall applications. The lower image shows the hypoxic zone in the Gulf of Mexico. Nitrogen losses from cropland is mainly the culprit there. And we'll hear more about that today from Dr. Wilson and Chryseis' presentations. Next slide, please. Ag retailers have valuable products and services which can keep nutrients on cropland and out of our waterways. Here's a list of some that can help reduce phosphorus losses, along with some very rough average reductions based on published studies. There's lots of variability in the published numbers based on soil type, slope, proximity to surface water, and other factors, but these rough averages give us a sense of where we can likely make a difference. Cover crops, soil testing, grid or zone sampling, and variable rate application, custom application, are all revenue generating opportunities to reduce phosphorus losses. Ag retailers can also let farmers know when a broadcast application has been made, so farmers can get out there and get the application covered or worked in a little bit. Avoid application before heavy rain events, abide by setbacks, and let farmers know when we see an issue that needs attention, such as a tile blowout or water restrictions, those types of things. Applying only enough phosphorus for the following crop rather than the next several crops in the rotation can also make a difference. Today we'll hear a great overview of some of the issues we're facing with nutrient losses. Ag retailers are making a difference. For example, our annual surveys show large increases in variable rate P application in the Sandusky River watershed, increasing from 17% of acres serviced in 2011 to 66%. In 2015, we secured funding for ag retailers to offer a discount on VRT to farmers in the Sandusky River watershed who had not used it before. We expanded to 3 additional watersheds in Northwest Ohio last year. We've had more than 30 ag retailers participate, along with 240 growers. Using published estimates, acres of VRT here alone represent more than 1 million pounds of phosphorus from leaving cropland in the watershed. We need to track and report the improvements we're making so that regulators and the public are aware of these voluntary efforts, using the power of the marketplace to drive improvements. You'll hear more from Julia about some additional tools and resources we have for you to use as we work to achieve these goals. With that, I'd like to turn it back to you, Julia.
Thank you, Mark. As Mark mentioned, we do have some free resources available on our website, partnershipfarm.org. On the left is our continually updated agronomist handbook, available free for download. The handbook includes algal bloom updates, trends in customer product and service adoption, and fact sheets that you can provide to grower customers to increase awareness of products and services that reduce nutrient runoff. Our phosphorus loss reduction wallet cards are on the right, which can be ordered for free on our website as well. These are a great conversation starter with your grower customers and can also serve as handouts in meetings. To date, we have distributed more than 25,000 wallet cards. Our next webinar will occur on December 11th and will discuss agricultural equipment. Please note that we do take into consideration your suggestions for webinar topics, so be sure to fill out our evaluation form after the webinar. We also invite you to follow us on Facebook and Twitter for PARM updates and industry news. Today's webinar is sponsored by Purdue University's Center for Food and Agricultural Business. We will now hear from Betty Jones-Bliss, Associate Director for Purdue University's Center for Food and Agricultural Business.
Well, thank you, Julia, and good morning and greetings from Purdue University. We're sitting in the snowy Midwest today. So I am pleased to let you know that our ARA Management Academy will be held for the 13th time in January 2019.
One second, Betty. Can you share your PowerPoint slides?
Yes.
There you go.
Okay, you can see them now.
They were up for a second and they went away again.
Okay, are they now? Are we good?
Nope, they're still not there. Do you have the PowerPoint open on your screen?
Yes, I do. And
there it is.
Okay.
Okay, go ahead.
I'll blame it on the snow. So again, good morning. I'd like to just talk a little bit about our ARA Management Academy. We're in the 13th year. We'll be delivering in January 2019. Our partnership with ARA has been a long-standing, almost 15-year relationship. And then 2 years ago, we brought Arizona State University into the partnership for the delivery of the ARA Management Academy. It allows us to capitalize on their excellence in supply chain management and operations, and it gives us a delivery location that has different crops than that we have here in the Midwest, and that has been of interest as well. So why has the Academy been successful in drawing ag retailers from across the country each year? I think that I could sum that up in one word, and that's change. Change is our constant. Our competitive landscape continues to change. And so to address those changes, we really have to look at our people. We've got to sharpen their business acumen. We've got to focus on people's leadership skills to manage the challenges that we face. Who should attend the Academy? I get that question quite a bit. It's really for experienced people and for those who are are going to move into increased responsibilities. For those that are experienced, it's a good way to refresh understanding of best management practices and approaches looking across the business. So if you or your employees are interested in looking across business functions, the Academy is a really good choice. So during the Academy, we take an approach, as I said, to look across the business. We will really look at what does it take to think strategically. We know how important that daily operations are, but this need to think strategically, to think about what's coming in the future is really important. From a financial standpoint, how do your responsibilities, how do the decisions that you make impact your business's bottom line? We'll look at some timely tools for leading employees. If you don't have somebody that is a direct report, these tools work as you influence across your team and up and down and sideways in the organization. We'll really pinpoint ideas for finding efficiencies. I think we're always looking for efficiencies, and that's the focus in the Academy when we look at operations and supply chain. Where can you be more efficient? How can you drive cost and time out of the supply chain? We'll really look at how you're working with customers. How with those key customers, do you truly understand their values and their goals? And once you do, how can you work with them? We call it co-creating value. How can you work to partnership with those key customers? So that's a little bit about some of the topics. For us, those delivering the ARA Management Academy, it's really important that you go back to work with actionable steps. So you do make an action list before leaving. So again, it's 3 days in Tempe, Arizona. A lot of networking opportunities across the industry. And I think the most important is taking time outside of work to really dig in and think about your role and responsibilities. Again, make that list of action steps so that you have an impact when you get back to the workplace. There's 7 CCA credits available for attending the 3-day program. If you had questions, please contact me at the following email or phone. Be happy to talk with you further. Also, the website has more information about the schedule and registration. There's a link here, but Googling ARA Management Academy should bring that right up. So appreciate the time today to talk about the ARA Management Academy and to be a sponsor of this webinar. So thank you so much, Julia.
Thank you, Betty, and to all of Purdue University's Center for Food and Agricultural Business for being our sponsor today. Now, we'll get the presentation started with Dr. Melissa Wilson, Assistant Professor and Extension Specialist in Manure Management and Water Quality at the University of Minnesota.
Thank you so much, Julia. Can you see my screen okay?
Yep, looks good.
All right. So as Julia mentioned, I'm an assistant professor and extension soil scientist at the University of Minnesota, and I focus on manure research. And I just started in August 2017. So a lot of the stuff I'm going to talk about today is kind of our preliminary data, things we just finished up this year before we got all the early freezing temperatures. One of the first things I want to talk about before we get started on my research is looking at some manure data. I think one of the important things for you as ag retailers to think about is that the nutrient content is going to vary by animal type, but it's also going to vary within animal species as well. And to illustrate this, I contacted some local labs to Minnesota. These are commercial labs, and asked them to send me their manure analysis data. And I actually got about 54,000 data points from 2 different labs. Most of those, about 33,000, were actually swine manure, so I'm going to start with them. What we see here is the nutrient content, and this will be in pounds per 1,000 gallons since it's liquid. We'll also talk about some solid manures, so that'll be pounds per ton. And we see the different kind of constituents. In the dark red, we have total nitrogen. In the light red, we have ammonium nitrogen. Ammonium nitrogen is a form of total N, so it's considered to be part of this total N, but it's the part of total nitrogen that's actually immediately plant available. I also looked at phosphate here in yellow and potash here in gray. The middle lines you see in each of these blocks is the average value, and then the actual box itself shows you the middle 50% of all the samples. Then these lines show you the minimum value found. So in this line, swine liquid manure, it's often 0 or close to 0. And then the maximum values. A lot of these maximum values actually go way beyond 100 pounds per 1,000 gallons. And I'll show you those in a minute, but I had to zoom in to show you these boxes a little closer. So this is what swine liquid manure looks like. Then we have poultry litter. We also wanted to look at beef solid manure and dairy liquid manure. So one thing that you should notice right away is all these different species clearly have different nutrient contents. The swine liquid manure and the poultry liquid manure tend to be hotter stuff. They have a lot more nutrients per unit manure versus the beef solids and the dairy liquids. They tend to be a little more dilute, so they have less nutrient per unit manure. But they're all still really good sources of nutrients. The other thing I wanted to point out is the crazy amount of variability we see in these. So for instance, say you think you have a swine liquid manure and you're just using an average book value. So say you think you have about 40 pounds per 1,000 gallons of nitrogen. But what if you actually only have 10 pounds of nitrogen? Or what if you have 100? that could cause problems in either way. So one of the things that we kind of emphasize with this is that testing manure is really important to actually know the nutrient content. Now we're going to zoom out here and show you the nutrient content with the maximum values. And you can see some of these get really high. Some of these could be errors. Maybe someone mixed the manure in a bucket that had fertilizer in it or something. But you'll see that we do still see high values across all the different species. So again, the take-home message is if you're working with farmers who are applying manure, make sure they're getting their manure tested pretty regularly. For instance, if you have an operation and you test it every year for 4 years and the manure is really consistent in its nutrient content, then maybe you only need to actually sample every couple of years. But if it's something that changes every single time and the nutrient values change pretty drastically, I would continue looking at it probably at least once a year. The other big thing is use clean containers. We've seen instances here in Minnesota and in Maryland, where I worked previously, where people accidentally mixed their manure in a bucket that had fertilizer in it, and then that kind of spiked the manure. So you got to be using clean containers. The other thing that's really important is making sure that you have a representative sample. You got to mix this stuff really well. Manure is not a homogeneous product. It's very heterogeneous. So for something like maybe you have a turkey litter or a poultry litter pile, try to dig through the crust. The crust is not representative of what's in that manure pile. Dig in a little bit and then get a bunch of subsamples from different areas in the pile. Mix them all together in a 5-gallon bucket, mix them really, really well, and then take a smaller subsample and send that to the lab. If you're doing something like liquid manures, we often suggest taking small subsamples out as it's being pumped. So maybe every foot you draw down the pit, you can take a sample. Again, putting it in buckets and mixing really well, and then taking a smaller subsample of that and sending it to the lab is really important. We notice there's a lot of stratification with nutrients in manure, especially with the liquid manures as you pump down a pit, even if it's pretty well agitated. So it's important to mix those really well. All right, so let's get into the manure research that we're working on. As I mentioned, a lot of this is preliminary results, kind of 1 year of studies. I'm going to talk about some winter manure applications where we applied manure on top of snow. We also looked at manure nutrient availability of 6 different types of manure. Third project is side dressing manure into corn. We wanted to see if we can open up the window of opportunity for applying manure in different time frames. And then finally, integrating cover crops. What can we do to capture some of those nutrients if we're fall applying manure? So first off with the winter runoff plot. What we wanted to do is see with dairy manure, because we still have some daily haul operations up here in Minnesota, if it's more liquid or more solid, does that make a difference when we're considering what might run off during snowmelt? So we actually went out earlier last winter and applied these plots. These are gray frames here, are just that, they're frames, and you can still see the soil at the bottom. And what that does is it allows any snow that falls into these frames to run off down through these pipes and into the trash cans, and then we can collect the frames, or the runoff. So what we did is we took some raw manure from a dairy barn here on campus, and it was running about 14% solids, and we applied that to 3 of those plots. We took some of the manure we had left over and diluted it down so that it only had about 3% solids, so we just added water to it to get that, and applied that to 3 of those frames. And then we had 3 frames where we didn't have manure to see if there was any kind of nutrients in the snow that would affect our results. So we waited until kind of late winter. We applied these January 24th, and then we did have a big melt up here in Minnesota right after that. And we collected our first runoff samples on January 28th. So this is what it looks like after that runoff event. It had frozen by this time again. So I pulled off the first lid of the first bucket, and you can see how dark this material is. And it smelled just like the dairy manure. Pulled off the second lid of the second container, and again, it was very black. And I was like, I thought it must have been sediment. I didn't think that that could have possibly been just manure. But I pulled off the lid of the third bucket, and sure enough, that water was clear. So clear you could see the sediments that had fallen into the bucket from the plots at the bottom. So this is one of the things I want to point out with why people have trouble with manure applications in the winter. It's because a lot of that manure is going to end up in the ditches. And when you have neighbors or non-farming people who see that, that's when we start seeing complaints. So again, really kind of illustrates why applying right before a big runoff event or when you know a big melt is coming is not a good idea. Just to show you what this looked like, this is about a month later. We collected a third melting event, and still the solid manures was still pretty brown. The water smelled like manure. In the liquid manures, the water was a lot clearer, but it still had kind of a manure smell to it, versus the non-manured plots was very clear and didn't have the smell. So even after a couple events, this stuff was still kind of showing up in some of the water, unfortunately. Now, one of the things we looked at was phosphorus. We're looking at nitrate too, but I haven't gotten that data back. What was interesting was the first runoff event with the liquid manures actually had more phosphorus, which was surprising because we applied less total phosphorus with the liquid manures because we just diluted it. So we were surprised to see that. What we think happened is when you have more liquids, it kind of runs into the snow and mixes with it, and then that phosphorus can melt with the snow a little easier. Versus the more solid manure, that just kind of stayed on top of the soil or on top of the snow. So we think that that was holding on to the phosphorus a little better. But by that third event, which you see here, there was more phosphorus in the solid manure runoff than there was in the liquid. So that suggests that with the liquid manures, you're going to see bigger flushes of nutrients, particularly phosphorus runoff. But over time, the solid manures are still going to kind of have those little smaller flushes. But we have yet to see which one over cumulatively or added up lost more phosphorus. So that's something we have yet to put together, but should be interesting. And we did just install our frames again for this year. It froze really early, but luckily we got them in right before the soils froze. So we'll be running this for a second year. All right, my next topic is manure nutrient availability. Here in Minnesota, we typically try to calculate the plant available nitrogen from the total nitrogen in the manure. And we have some tables that farmers or ag retailers, ag specialists can work with to try to determine how much total nitrogen or available nitrogen will be available that first year. So it's going to depend on species and how fast you can get that manure incorporated into the soil. So for something like beef manure, if it's a liquid manure and you're able to sweep inject it, we assume about 60% will be available that first year of the total nitrogen. Versus if you leave it on the ground for over 5 days, or if you don't incorporate it because you're doing no-till, maybe only 25% is going to be available. But all of these numbers have been established for a couple decades now. So I wanted to see, are these numbers still valid? Are there differences? You know, we have new technologies. With dairy, we're seeing a lot of liquid-solid separation. Does that change the dynamics? With beef, we have a lot of bedded beef pack systems, but we're starting to see more liquid collection systems as well. We actually have a lot of barns being built with deep pits for the beef. So again, will that influence their nutrient availability? So we did these in field experiments with small plots. We have 2 locations at 2 sites in southern Minnesota, with Sika, Minnesota's location 1 and Lamberton, Minnesota's location 2. And we got 6 different types of manure and applied both at nitrogen-based rates, or all 6 rather, at nitrogen-based rates of 140 pounds per acre. So we followed our own recommendations and applied manure enough to supply 140 pounds of nutrients. So what we'll do is we did that at site 1 at each location this year, and we applied manure in this first year, 2018, and then we're just going to watch it for 4 years. We're not going to apply any more nutrients, but we're going to see how much nutrient was supplied from that manure in year 2, year 3, and possibly see if there's anything even in year 4. And what we'll do is we'll start the experiment again at a second site at each location. So next year we'll do it again in another field, and hopefully maybe we'll get different weather conditions. At Site 1 this past summer, we had really wet conditions pretty much the entire year. So maybe we'll get different conditions next year and see if that influences the manure differently. Now, besides those plots, what we did is we also added some fertilizer plots to develop response curves, so that way we can compare our manure to known quantities of nutrients. For instance, we did 0 nitrogen with full P and K. We also did 30% nitrogen, a plot with 60%, a plot with 90% nitrogen, and a plot with 120% nitrogen. And we did that with phosphorus as well. So 0 phosphorus, but full nitrogen and potassium, 30 pounds phosphorus, 60 pounds phosphorus, and 90 pounds phosphorus, just to see if we can compare those to our manure plots. So overall, we had 16 treatments. Applying these was fun. We had small plots, so we had to do this all by hand. So buckets for the liquid manures. We had some foaming issues with our swine manure. As you can see here, it was overflowing even though the manure was only about 1/3 full. So we had lots of fun times. Here you have our liquid manure. This is liquid dairy manure applied right next to the bedded beef pack. So we applied all of our manures and then incorporated pretty quickly, within 6 to 12 hours, depending on how long it took us to get everything applied. So some results. We took a lot of pictures this year. This was a picture taken June 18th at the Waseca location. And here we have some of our turkey litter plots right next to a bedded beef pack plot. And you can see the turkey litter corn looks way better than the bedded beef pack plot. One of the things we think was happening is that bedded beef pack had a lot of bedding in it. So we suspect our carbon to nitrogen ratio was really high, and it was probably immobilizing some of the nitrogen. So again, we applied these based on our own recommendations to supply the same amount of nitrogen, and we just weren't seeing the same amount of nitrogen. So maybe we do need to update some of our things, but we're only 1 year in, so we'll continue looking at it. Here's some aerial photos from our second location at Lamberton. You notice we did this with multiple replications, so here's just 2 reps. We actually did 4. And it's kind of interesting to see what plots look good and what plots look bad. For instance, 0 nitrogen fertilizer looks pretty yellow. The corn isn't closed. The rows haven't closed nearly as much. Our bedded beef pack actually looks kind of similar. Again, yellow and not very closed. Versus some of our other manures look really good. The turkey litter looks very good. The composted chicken pellets looks really good. Our liquid separated dairy looks fairly good. And you can see that's kind of the same pattern in the second rep too. The bedded beef pack looks bad, turkey litter looks good, and so on and so forth. But we have yet to we got our yields, but we haven't kind of crunched the numbers yet. We also looked at soil nitrate in the top 2 feet throughout the season, soil phosphorus as well. So we'll have lots of interesting data in upcoming years. So next experiment is our side dressing manure into corn. They've been doing this in Ohio for a couple years. Glenn Arnold is a researcher who's been working on this, and he's been showing some really good data. So we figured, hey, why not try it up here in Minnesota? We have a little bit higher organic matter in our soils. We're also a colder climate, so let's see if we can get this to work. So this particular experiment, we wanted to go ahead and just use full-size equipment. So this is an on-farm experiment down in southern Minnesota. In this field, we're in a corn-soybean rotation. So we actually went in after the second year, or after the first year of corn before the second year. We applied 40 pounds of nitrogen and starter to the entire field. Our farmer really felt strongly about putting on some starter, and we agreed with that. So then we side dressed 140 pounds of nitrogen with various sources at the V4, V5 stage. And we compared 4 different treatments. Swine manure, we applied it with a drag line. It was about 3,500 gallons per acre, and this is from a finishing barn, so pretty nutrient dense stuff. We also tried side dressing anhydrous ammonia. This is what the farmer typically does in that region. We also looked at liquid UAN, which is 32%. And we looked at no nitrogen side dress. So these treatments only had that initial 40 pounds of nitrogen in the starter. We just wanted to make sure that there was, in fact, response to nitrogen. So here's a picture. Yeah, the drag line definitely knocked over a bunch of the corn. In a lot of cases, like this first row here, that stuff just popped right back up. If you hit it before the growing point comes up, it seems to pop back up pretty well. In some of the wetter areas, kind of the second row here, sometimes when the soil was dragged up over the corn, you could see that had a little bit of a harder time coming back up. But generally, we were pretty impressed. If you want to check out a video, check out our YouTube account at UMN Manure. Just Google it and you should be able to find it. And you should be able to see our video on this. It's kind of interesting. Here's an aerial photo. This is taken late July. And I've labeled 2 of our replicates. You'll notice we actually did 4 in this field. You'll see the 4 stripes where we had no side dress nitrogen. So you can definitely see there was a nitrogen response. And the swine manure you can see here, we had to turn around about 3/4 of the way through the field just because that's the length of hose that our manure haulers brought. What's interesting is the striping we saw. We think that when they cleaned out their equipment after this first rep, which you don't see as much, this is where the liquid swine manure is applied in the first rep. We didn't see as much of the striping, so we think something must have clogged our hoses in between those, because you see the exact same rows of corn are impacted by the striping kind of in all these replicates afterwards. So we were a little worried about that. Our anhydrous plots looked really great. Our UAN plots looked really great. So we had some concerns about the swine, mostly because of kind of application issues. But here's our yields. We have anhydrous ammonia, the UAN, the control, and the drag line. And we averaged a little over 200 bushels per acre at 50% moisture, 15.5% moisture, with all these different treatments. About 208 bushels per acre for the anhydrous ammonia, and roughly a little under 205 for the UAN and drag line. And based on the variability, which you see by these variability lines here, this is the standard deviations, there was not enough evidence to suggest that these were statistically different. So that's why you see these letters that are the same above this bar. Now, the control has a B above it, and that means it was statistically different from these other nitrogen sources. So, yeah, nitrogen definitely helped this field. I thought it was interesting that we still got 140 bushels per acre with only 40 pounds of nitrogen, though. I know that's a very low yield, but that's still a good bit of yield with not very much nitrogen. So, kind of interesting. We have very high fertility soils here. So, our next year's plan is basically to repeat the experiment in a new field. We're also going to go back to that same field where we're going to have soybeans this year, and we're going to test that and see if there's any impact of the soybeans, because we have manure which has micronutrients versus the anhydrous and the UAN maybe didn't have some of those things, so we'll see if there's an effect on the soybeans. We're also going to look at a secondary experiment where we're going to drag corn at V1, V2, V3, V4, V5, and V6 with a hose and see if there's a point where you don't want to drag corn anymore. And we're hopefully going to look at 2 corn varieties. We want to look at something that's a little more prone to kind of snapping during wind storms versus something that's not as prone to doing that, and see if there's a difference in varieties in what you might want to use for dragging a hose through it. All right, my last study is looking at integrating cover crops with manure. Here in Minnesota, we recommend if you're fall applying any kind of nitrogen source, you want to wait until our soil temperatures are cool, so about 50 degrees Fahrenheit. Unfortunately, in Minnesota, we have a very short window of opportunity to get things harvested and get manure out, so sometimes farmers are applying it when it's still pretty warm, just because that's when they can get into the field. So we wanted to see, can a cover crop help with that? Can it help take up some of those nutrients? So there's a study that just finished up. What they did is they drilled a rye cover crop after either silage corn or soybeans. And then later in the season, when the soil temperatures cooled a little bit, they did inject liquid manure. Once they terminated the rye in the spring, they measured soil nitrate in the top 24 inches of soil and in the rye. And then these were at on-farm experiments, about 19 locations across the state. And at each farm, they had these strips where they had the rye and strips where they didn't have rye. So that way they can compare where the cover crop was and where the cover crop wasn't. But manure was applied over the entire field. Then they went back in the following year and harvested the corn that was planted, either for grain or silage, and then measured the nutrient uptake in the corn as well as the yields. And we'll talk about the yields. So this was done over 2 crop years, like I said, at 19 locations. Here shows our locations. We had kind of central Minnesota locations versus kind of southern Minnesota locations. The red represent where we use dairy manure, and the yellow represent where we use swine manure. So we use a variety of different manure types. As I mentioned, this is all on farm. So lots of different equipment types and things like that were used. And all of these were single year sites. So we used a different field with the exception of this Blue Star, where we did it in the same field 2 years in a row in the silage system. So first up is the spring soil nitrate. Right before we killed the rye, they went in and measured the soil nitrate in the top 2 feet. In the green is where there was a cover crop, in the yellow where there was no cover crop. And you see there's a difference between central and southern Minnesota. Southern Minnesota had better growth, it's warmer, so there's less nitrate in the soil, versus in central Minnesota where cover crops weren't quite as big, so they didn't take up quite as much. But if you average these together, we did find that underneath a cover crop, there was about 123 pounds of nitrate per acre, versus where there's no cover crop, there was 202 pounds. So that's a difference of about 79 pounds of nitrate per acre. And in early spring is when we see most of our losses in Minnesota, getting through to the tile drains or leaching and things like that. When the snow is starting to melt and we're starting to see water moving through the soil profile again. So that's a lot of nitrogen that could potentially be lost, and instead is being held up by the cover crops. Next thing people always ask about is, what about the yield? How did that impact the corn afterwards? Well, here's all of our different sites that harvested corn grain for yield, or corn grain. And the green is where there was a cover crop, and the yellow is where there was no cover crop. And on average, the cover crop corn yielded about 197 bushels per acre versus the no cover crop was 199. And again, you can see at each of these different sites, there's enough variability that this was not necessarily a trend. So this was not statistically different. In some sites, we saw where the cover crop had kind of give you a yield bump, versus in some sites, the cover crop maybe caused a yield decline. So the thing I wanted to point out is that can happen in each of these individual fields, but you'll notice it's pretty random. And we see this with our silage as well. Again, the green is where there was a cover crop, the yellow is where there was no cover crop. In some cases, you saw where there was a yield hit, in some cases, there was a yield bump. But on average, our silage yields were about 20.7 tons per acre versus 20.8. So again, no statistical difference there. But the reason I like to show people the individual sites is because if you're working with a farmer who wants to use cover crops and maybe they have a one bad year, really try to encourage them that, you know, that's kind of random chance. Sometimes you're going to have a bad year with it, and sometimes you're going to have a good year. So it's just one thing I like to show people. Take-home messages: equipment matters. Try to use something that minimizes surface disturbance if you're going to apply into cover crops. We found sweeps with small knives seem to help minimize disturbance. If you have other kinds of equipment that do this, this will be good as well. The things that really churned up the surface, the rye didn't do as well with that. We did find that winter rye can conserve some of that manure nitrogen and potentially reduce nitrogen losses. And on average, the corn yields were not impacted following the cover crops and manure. Some years you may see the yield hit, sometimes you may see a yield bump, but on average, that's just kind of random chance. On average, we didn't see any problems with the cover crops. So what are we doing in the future? I just got a Natural Resources Conservation Service grant to look at trying to establish those cover crops earlier and get more growing roots into the ground. So we're going to try interseeding versus kind of that drilling after harvest standard. And we're going to apply manure early versus late, again, to see if there's a difference in, if we apply it early, can the cover crops take up some of those nutrients? All right, that is all I have. So I want to say thanks. Here's my contact information. Follow me on Twitter. And I also wanted to emphasize how our research is being funded currently. Our Minnesota Ag Fertilizer Research and Education Council, the Pork Board, Soybean Research and Education Council, as well as the Sugar Beet Research and Education Board of Minnesota and North Dakota. That's it for me, Julia.
Okay. Thank you, Dr. Wilson. There will be time for questions for Dr. Wilson at the end of the webinar. For now, we'll turn the presentation over to Chryseis Modderman, Extension Educator of Crops and Manure Management at the University of Minnesota Extension.
All right. Hello and good morning from the Arctic tundra of Minnesota. Let's see, hide control panel, that's what I want. There we go. Okay, like Julia said, my name is Chryseis Modderman. I'm an extension educator with the University of Minnesota Extension, and I focus mostly on manure nutrient management. And today I'm here to talk about water quality issues from manure in the Great Lakes Basin and some of the best management practices to deal with those issues. So let's start out by talking about the Great Lakes Basin. And here's a map of the land use for that region, plus a couple of major river basins. So the dark lines around each lake here are the basin for each lake. And then there's the Mississippi, Ohio, and Red River basins included in this map too. But we're just going to focus on the Great Lakes here. And you can see in the legend over here that most of the land here is colored yellow and green, and that stands for forest and agricultural land. And the red spots you see here are urban centers, like that's Minneapolis, St. Paul, Chicago, Detroit. And about 1/3 of the Great Lakes Basin is used for agriculture. And that's what we're here to focus on today, specifically manure in agriculture. And so here is Great Lakes Ag by the numbers. So it's about a $15 billion industry every year. And in this region, there's more than 55 million acres used for agriculture production. All right, these are eco-regional maps of Minnesota. And this is my home state and where I work, but I'll try not to be too focused on just Minnesota throughout this webinar. And the Minnesota-specific things that I do mention are usually also applicable to most of the Great Lakes Basin. So Minnesota and the Great Lakes area are fortunate to have the resources to produce large amounts of both livestock and crops. Now in this map, the one on the left shows where each livestock type is produced, and the one on the right shows where different crops are grown in the state. And the actual livestock species or crop types is not what I'm trying to show you here. I just want you to see that livestock and crops are produced geographically close to each other, so side by side. And this isn't always the case around the country. Like there's areas of Texas where you have huge areas of cattle production without a field of crops for many miles. So for them, transportation of manure can be very costly. So we're lucky to have this arrangement because it makes manure very valuable as a fertilizer because of the proximity to crops. And just to drive that point home a little more, here's the daily manure produced by different types of livestock. On the left are the livestock types, and on the right is the total manure produced, and that's in pounds per day per 1,000 pound animal unit. And dairy cattle produces a whopping 80 pounds per day per 1,000 pounds of animal, and that's a lot of manure to deal with, and therefore a lot of nutrient value. So besides nutrients, manure has many benefits for the soil, like increasing soil organic matter, which improves soil health. And that leads to all the things that, are good things from increased organic matter in the soil, like improved infiltration, water holding capacity, and manure and commercial fertilizers have also been shown to produce similar yield results. And manure can sometimes cost less than commercial fertilizers. So while we all know that manure has many benefits that make it a great nutrient resource, it is faced with some challenges. including nutrient pollution of waters. And the Great Lakes are the largest system of fresh water in the world. They account for a whole 84% of the United States' fresh water, and 21% of the world's. And that water is a very important resource. So it provides habitat for many species of wildlife. We use it for boating and fishing and other recreation. And about 40 million people get their drinking water from the Great Lakes. So it's important to protect that quality of water. One of the main ways that water quality can be harmed is through nutrient pollution. So listed here are the 14 elements essential for crop production. And they're separated into macro and micronutrients based on how much is needed for plant development. And though macronutrients usually get the most attention, nitrogen, phosphorus, potassium, manure is a good source of both macro and micronutrients. And of these listed here, nitrogen and phosphorus are most likely to cause water quality issues. So they're the ones that I'm going to focus on here. So let's start with nitrogen, specifically nitrates in groundwater. So in Minnesota, we are worried about nitrates in groundwater because about 75% of Minnesota residents get their drinking water from wells or groundwater. And the sources of nitrogen to contaminate groundwater are mostly caused by people, and that's including agricultural fertilizers, also sewage or nitrous oxides that are produced from combustion of coal and gas. And the most common form of nitrogen contamination found in groundwater for drinking water is nitrate, and that's shown by the graph on the right here. And other states in the Great Lakes Basin that also use groundwater for drinking water follow many of these same trends. And the Great Lakes Basin, there's a huge amount of groundwater, so much that it's sometimes called the sixth Great Lake, and it's estimated to have as much water as Lake Michigan. And these are the different groundwater aquifers. Some of them supply drinking water, others feed the Great Lakes directly. And the maximum level of nitrate that's allowable in drinking water is set by the EPA. It's 10 parts per million. About 10% of wells in Minnesota exceed that limit. And it's important because increased nitrates in drinking water can cause a condition that limits oxygen supply in the blood that most often affects infants, and it's called blue baby syndrome due to the bluish color of the skin. And if we back out to look at the whole country here, this is what we see for nitrate contamination in groundwater. So looking at the legend down here, the blue areas are less than 1 part per million, 1 to 5 is yellow, 5 to 10 is orange, and over 10 parts per million is red. And that over 10 would be the one that is above the level that's considered safe. If you look around the Great Lakes region up here, it's mostly yellows and oranges you see, so about 1 to 10 parts per million. And these are the total nitrogen in each lake, and this data is from 2011. So along the x-axis down here is each lake, and for each lake you can see how much nitrogen enters them directly through tributaries, and then there's the total nitrogen. And along the y-axis here is the total annual load in tons per year. And each color within each bar shows how much of that nitrogen comes from each source, shown over here in the explanation box. So the red bar that's the second from the top indicates how much originates from manure. It's a little confusing that there's 2 red bars within each bar. I'm not sure why they couldn't find a 5th color to use in their research graph. But you'll see that in each of these, manure contributes very little directly to each lake, and that's shown by the bar on the right for each lake. The manure section here is very minimal. And most of the nitrogen pollution comes from tributaries for manure. And nitrogen for manure and nitrogen overall is of biggest concerns in Lake Michigan and Lake Erie. So just a kind of a sidebar here, there's a new groundwater protection rule in Minnesota that gets a lot of attention. So I want to talk about that for a moment, since it's a common question that we get. And I want to lead with the fact that manure applications are not part of this rule. The Minnesota Department of Agriculture, the MDA, regulates commercial fertilizer, and the Minnesota Pollution Control Agency, the MPCA, regulates manure. And since this rule's from the MDA, it only applies to synthetic commercial fertilizers. So in a nutshell, this is a rule designed to protect groundwater from nitrate contamination. It states that you can apply over 40 pounds per acre of nitrogen fertilizer in the fall or on frozen ground if your farm's on a vulnerable groundwater area. Now there's a bunch of exceptions to this rule, mostly for actively growing crops like pastures or winter wheat. But how do you know if you're in a vulnerable groundwater area? Well, they've got a map for that. The purple areas here are considered the vulnerable groundwater areas. And they decided which areas were going to be considered vulnerable based on if they had coarse textured soils, shallow bedrock, or karst geology. And they also have an interactive version of this map, so you can zoom right down into your land to see if it falls in a vulnerable area. All right, now let's shift gears a little bit and talk about phosphorus. So phosphorus contamination in surface water in Minnesota is a major concern. Atmospheric deposition and agriculture are responsible for most of it, as is shown in the graph on the right here. And on the left are the areas of Minnesota that deposit the most phosphorus into surface waters, with red indicating high levels, green indicating low levels. And if you remember that graph I just showed you for the nitrogen in the Great Lakes, well, this is the exact same thing, just for phosphorus. But you'll notice that this time in the explanation box, they separated manure into unconfined and confined types. So now we're focusing in on the second from top and third from top, these two bars, the maroon and the other red, reddish orange, I'm not sure. What I want you to see here is in this study, they found that the unconfined manure, the maroon bar, shows that unconfined livestock operations really didn't contribute a lot to the phosphorus in the lakes. It was the confined livestock systems that were more so the problem. And just like with nitrogen, phosphorus levels are of most concern in Lake Erie and Lake Michigan. So why is phosphorus contamination of water a problem? Well, it's considered the top cause of eutrophication, which is excess algae and plant growth that depletes water oxygen in fresh water. The water oxygen depletion is called hypoxic conditions, and they cause fish kills and loss of habitat for aquatic life. And that happens when the algae dies and is decomposed by microbes in the water. And it's actually those microbes that are using up the oxygen in the water. Now, all of the Great Lakes have seen excessive algae growth at one point in their history. You can see here that the main sources of eutrophication are runoff from agriculture and livestock, as well as residential and urban areas. So how do algal blooms form? In freshwater, phosphorus is the most limiting factor for algae production. So when phosphorus is added, algae grows out of control. And they can be really devastating because they take very low concentrations of phosphorus to get them started, only about 20 to 50 parts per billion. And that's parts per billion, not million. And they tend to happen later in the summer because they need relatively high temperatures to occur. Now, harmful algal blooms are a type of algal bloom that's caused by phosphorus as well, and it can also cause loss of habitat for fish and aquatic wildlife. The majority of harmful algal blooms are caused by cyanobacteria, and that's also called blue G blue-green algae. And while it's technically a bacteria, it acts pretty much like an algae. And the problem with cyanobacteria is that it produces cyanotoxins that can cause a whole host of health issues in people and animals when it's consumed. And this can pose a big issue for people that use these water bodies for drinking water or for recreation. Now in 2016, 19 states reported harmful algal blooms that were bad enough to shut down beaches or cause health advisories. And those states are shown here, green with the diagonal lines through them. You can see that Illinois, Indiana, Ohio, Pennsylvania, and New York from the Great Lakes Basin are all included in that. And while Minnesota, Wisconsin, and Michigan didn't have those issues in 2016, they still had anecdotal reports of harmful algal blooms. And that's shown by the states that are colored in just green without the diagonal lines. So now, of course, we have to talk about Toledo. One of the worst case scenarios with harmful algal blooms was in Toledo, Ohio in 2014. Now, most of Toledo and the surrounding area gets their drinking water from Lake Erie. And when they had the really bad algal blooms in 2014 from industry and ag runoff, more than 500,000 people were left without drinking water when the water treatment plant couldn't keep up with how much contamination there was. So how can the Great Lakes region agriculture reduce nutrient pollution? Well, there's many nutrient reduction plans currently out there. There's programs that look at all the lakes together, like the Great Lakes Sediment and Nutrient Program. And then there's more state or single lake focus plans as well. So let's look at what practices are being recommended by these programs for farmers to use to minimize nutrient pollution. There was a study done on different best management practices for nutrient losses from farms, and these are their results. So across the top here are the different management types that they studied, and along the y-axis here is how much that management type affected nutrient loss. So if the bar is below the x-axis, like these, there was a decreased loss of nutrients. And if the bar was above, there was more loss. Now, I'm not a huge fan of double negatives like that, decreased loss, but just remember that a decreased loss is good here because you don't want to lose nutrients from your operation. And this shows that the practices that decrease nutrient losses the most we're having a nutrient management plan or a manure management plan. So an easy way to manage nutrient pollution, is just to have a plan and stick with it. And the goal of nutrient management planning is to improve the efficiency of nutrients. And that's so over application doesn't occur, which could lead to potential pollution and runoff. So this is all about getting down those 4 R's. And I'm sure you're all familiar with the 4R nutrient stewardship, but briefly, they're making sure you're using the right fertilizer source at the right rate, at the right time, and in the right place. So these are screenshots from the manure management plan template that the Minnesota Pollution Control Agency has. And large operations are required to have one of these, but we also encourage smaller operations to have them as well. They're just a good idea to make one. In its most basic form, you'll need to know about manure sources, your crops, crop rotations, and general field information to make a manure management plan. And in Minnesota, we have county feedlot officers that work with farmers to develop and review manure management plans. And there's also manure consultants out there that can help with that as well. So another thing that farmers can do to prevent over-application is not to view manure and commercial fertilizers as an either-or situation. You can use them both if you do it correctly. So one big limitation of manure is that the nutrient ratios are fixed, unlike commercial fertilizers that can be mixed to fit your crop needs. And with manure, it is what it is when it comes to nutrient content. And unfortunately, a lot of times when we apply manure at a rate that meets the nitrogen needs of the crop, it over-applies phosphorus. and that can lead to phosphorus runoff and pollution. But a management tactic for that is to apply manure at a phosphorus-based rate, and then supplement up nitrogen with urea or a different nitrogen source to get your nitrogen levels to where you need them. And you can talk to an agronomist or your co-op to help make plans for this, especially on the commercial fertilizer side. And another way to keep your manure where you put it is to incorporate it into the soil. And here, time is of the essence, as you can see by this table over here. So down the left side, you've got your different livestock types. And then across, you see the % total available nitrogen. And that's in year 1, year 2, and then when it's broadcast, how long it took you to incorporate the manure. So you can see that the most nitrogen will be available if you incorporate within 12 hours. And if you wait 4 days, you're going to have a lot less nitrogen. So make sure if you're working with a custom applicator that if they plan to till in the manure or if you need to come back and do that yourself. So on the storage side of things, good stockpile or pit management are crucial to preventing nutrient loss. For pits, the liner is very important. You need to use a material that can't be penetrated by leaching. And you also need to make sure your pit's not in danger of overflowing. And this can take some planning, especially now in this time of year when we head into winter. You want to make sure you have enough storage space so that your pit won't overflow for the winter without having to apply on frozen ground or snow later on. And stockpile location is very important. You don't want the stockpile on a steep slope or in an area that might flood. And make sure you're checking up on your storage periodically so you don't end up with a leak in your basin liner that leads to leaching, or so you don't, find your stockpile sitting in a foot of standing water. Catch basins are useful for gathering any runoff that might happen from the operation. And berms and gutters are good for redirecting clean water so it doesn't flow through the feedlot or around the stockpile. And the NRCS is a really good resource for helping with storage systems. So they can help with the planning, the surveys, geologic investigations, and they also can help with designing things like water diversions and buffers. And there's some manure consulting companies out there that can help with that. Around here we have Central Crop Consulting just announced that they now have a engineering department that can help with manure storage. And buffers can be used to filter runoff from livestock operations and also from fields. So buffers are areas of permanent vegetation that filter out sediments and nutrients from the runoff before they can get to a waterway. And this is a diagram showing how buffers work. And in a nutshell, it's mostly through slowing down the velocity of the runoff. So once the runoff enters the buffer, the tall grass slows it down so it can infiltrate down into the soil where the nutrients are taken up by the plants or just diluted in the soil solution. And you all already know this one. I shouldn't even need to mention it, but I'm going to mention it anyway. Don't apply manure to frozen ground or snow. If the manure can't get down into the soil, it's at much higher risk of becoming runoff. And your buffer isn't going to help you here. Look at this picture. I mean, this buffer won't do you any good because there's no infiltration into it either. And most states do have regulations that limit winter manure applications. Something else you can use are two-stage ditches, which look like this diagram. So they have built-in floodplains called benches, and those are vegetated and generally about 2 to 3 feet above the bottom of the channel and about 10 feet wide on each side, which is kind of like having extra buffer strips that are there to help treat the water. So when the water level in the channel rises, it spreads onto the benches and it reduces velocity. Much like buffer strips, this is all about reducing velocity. because channelized water that's moving really quickly can be super destructive, eroding banks and the channel, which can cause any water that might have been carrying nutrients to escape and flood. The Nature Conservancy has been promoting the use of two-stage ditches in Indiana, Ohio, and Minnesota. But I believe as of now, you can only get equip funds for them in Indiana. And finally, I want to talk about cover crops. And Melissa talked about this in her presentation, so I'll just touch on it. So there's been some research to show that manure applied with cover crops will reduce nutrient pollution because the cover crop will sort of act like a vegetative buffer. It'll slow down the runoff so it can infiltrate. Cover crops will also take up nutrients and hold them in place so they don't leach away, especially in the fall. And those cover crops will hold on to those nutrients until they're terminated and the cash crop is planted and ready to use those nutrients in the spring. Now, this is a pretty new concept in Minnesota. There's been some exciting preliminary research done on it, like Melissa mentioned, and there's some more upcoming exciting research that Melissa's also heading up. We've seen a lot of interest in using cover crops and manure in Minnesota. Whenever it's brought up, people are very interested in it. But one of the biggest limiting factors in farmers trying this seems to be equipment, because you need a manure injector that minimally disturbs the soil so that it doesn't tear up the cover crop too much. So just to wrap it up here, manure should not be viewed as a waste product, but as a valuable resource. But it may also cause nutrient pollution if it escapes into waterways. And following the best management practices that I just went over will help reduce that possibility of polluting local waters. But remember that no single best management practice is a magic cure-all, magic bullet. There are different practices that might have different levels of success based on where you're located in the country, and some best management practices don't fit in well with certain crop management plans. So it's best to kind of use your best judgment, use a little bit of common sense, and use these practices in conjunction and combination with each other for best results. And with that, I thank you for attending today's webinar. Thank you for your time and attention. I hope you found it valuable. Feel free to contact me by email or phone, and follow me on Twitter. All right, I believe now I hand control back over to you, Julia.
We can leave your slides up in case for the question and answer you want to go back to any of them.
Okay.
So we'll get started with a couple of questions now. Attendees, please enter your questions into the question box on your screen for Dr. Wilson and Chryseis. And the first question that we'll get started with is anyone monitoring the accumulation of phosphorus at or near the soil surface as a result of the BMPs being used and or recommended?
I think I'll answer that. As of right now, we're not doing it necessarily in any Manure system, but we do have a couple people on board who focus particularly on phosphorus in Minnesota. We especially have one new hire that just started this past summer, so it's something that people will be looking at in the future. Right now in Minnesota, the emphasis is on nitrogen instead of phosphorus. I know kind of in Ohio and on the East Coast, there seems to be more emphasis on phosphorus, but right now a lot more people are focusing on nitrogen.
Okay, and the next question is, this I think is directed to Chryseis. The slide showing nutrient contributions to surface waters are greater from confined operations than unconfined operations. Any explanations for this?
Well, we can go back to that. I think the biggest factor for that is how concentrated the animals are. Usually in unconfined systems, it's, you know, cows out on a pasture, and there's, you know, the vegetated ground cover, the grass that, you know, would slow down any runoff, and many confined systems are more dirt-based feedlots, those sorts of things.
Okay, and next question. Do most livestock operations over-apply manure because they don't have enough acres to apply on?
Yeah, that can be, having the right number of acres for the amount of manure you're producing is one of those planning things you have to look at again. And I think I like to think the best of most people. So I think most over-application of manure happens when people just don't know their manure nutrient content. They're not exactly sure what they're applying. So, oh, well, a little more is better than, under-applying, which isn't necessarily true. That's why it's important, like Melissa mentioned, to sample your manure, also sample your soils so you know what you need for nutrients.
Yeah, I would tend to agree with that. Most of our states are pretty heavily regulated, especially with the confined systems, where they have to have manure management plans and they have to know where their manure is going. So as Christy said, I like to think the best of most farmers are trying to apply things properly.
Okay, and last question. This one is directed at Dr. Wilson. Why is it assumed rye reduced N loss if the crop yields were the same?
So when we think of N losses, I'm thinking of leaching particularly. We can also have gaseous losses. But what I was referring to in that study was we looked at the rye or the nitrate in the top 2 feet of soil right before we killed the rye and before we planted the corn. And we found that under the rye, there was less nitrate in the soil than there was where there was no rye. And the difference was almost 80 pounds of nitrogen per acre, of nitrate per acre. So that's why we assume that that can potentially reduce some of our nitrogen losses.
Okay, and in the interest of time, I'd like to wrap up the Q&A. I want to thank Dr. Wilson and Chryseis one more time for joining us today. We really appreciate you taking the time to share your work.
Thanks for having us.
At this time, I want to recognize our participating egg retailers. If you are an egg retailer in either the Great Lakes Basin or Mississippi River Basin that is interested in participating with PARM to benefit your business and surrounding water quality, please contact our project manager at caitlin@partnershipfarm.org. Also, look for our 2018 Egg Retailer Survey in your email or on our website starting December 1st. By participating, you will receive an individual report detailing your phosphorus and nitrogen loss reductions from specific products and services, along with an aggregate report that incorporates all survey respondents. Names and locations will be kept anonymous. Finally, I'd like to acknowledge our funders, collaborators, and members that made this webinar possible. In particular, the Great Lakes Protection Fund, the McKnight Foundation, the Clean Lakes Alliance, and a special thanks to Purdue University's Center for Food and Agricultural Business. We've also been enrolling corporate members to support our partnership. So we'd like to highlight our members, the Andersons, a gold member, and silver members, Garrity Ag Services, LLC, and Crop Production Services. Their contribution helped make this webinar possible and helps promote the strides that egg retailers like you are making to reduce nutrient impairments. If you are interested in becoming a member and receiving the additional benefits included, please visit our website, partnershipfarm.org, to fill out our online form. As we wrap up, please remember to look for the email in a few days with a webinar evaluation and webinar recording attached. I want to thank you all again for joining us today, and I hope you join us again for our next webinar in December.